Hey everybody, welcome to the Adventures in Brain Injury podcast. My name is Kevin Ballister. I'm a severe traumatic brain injury survivor, host of the Adventures in Brain Injury podcast, author of How to Feed a Brain, Nutrition for Optimal Brain Function and Repair, and I'm really excited to be here interviewing amazing practitioners and people doing really good work in neurorehabilitation. If you have not already, please leave a review on iTunes, feedabrain.com/iTunes. We'll take you right there. And you can support my work on Patreon, patreon.com/AIBI for Adventures in Brain Injury. So I'm really excited to have Dr. Robert Melillo on this podcast. We met at IAFNR and in 2019, I believe. And what we're going to be talking about is developmental functional neurology. Dr. Melillo is one of the world's most sought after and respected experts in developmental functional neurology, as well as brain imbalances, hemispheric integration, and the diagnosis and correction of most neurobehavioral disorders and learning disabilities. So his bio is extensive. He has done so much in these fields, including writing a textbook on neurobehavioral disorders of childhood from an evolutionary perspective. He has co-written many chapters in different books about ADD, about dyslexia, about attention deficit, and he's taught his own postgraduate level course for over 20 years. He has multiple graduate degrees in chiropractic neurology, neuroscience, and clinical rehabilitation neuropsychology. And he's the co-founder and president and past president of the International Association of Functional Neurology and Rehabilitation, which is IAFNR, where we met. He was recently part of Mark Hyman's documentary, Broken Brains, and he has created a line of vitamins and supplements called Kid Genius and True Genius. Along with his wife, Caroline, he has created a web series called Disconnected Kids, Reconnected Families. And he's written several books, and one of the best and most well-known is Disconnected Kids. So, without further ado, I introduce to you Dr. Robert Melillo.
Well, thank you very much. And you need to add to your intro that all the things you are, but you're also an inspiration to everyone that knows you. So that's what you should end it with. That you are an inspiration, because you are to me and you are to, I'm sure, everybody who's watching this. So thank you. Thank you for having me on. I'm excited.
That means so much, Dr. Melillo. Yeah, it is such a pleasure to have you here. You know, again, we saw each other at IAFNR in 2019 when I spoke last. And just your presentation of complex concepts and making them easy to understand in this hemisphericity model has been really useful. So let's just dive in here. What are brain imbalances?
Well, more often than not, there's something that start during development. And they essentially fall under an area of my research called functional disconnection syndromes or functional disconnectivities, which means that areas of the brain, as they're developing, they sometimes there's an imbalance in the speed and the development between primarily the hemispheres. It can happen between other networks, but predominantly because the hemispheres develop in a different way, and they develop in a different trajectory. Sometimes what can happen is that they can get out of sync with one another, where one side is maturing more than the other, or there's this what we call developmental asynchrony, where one side is growing faster than too fast, or the other side is growing too slow. And this developmental maturational imbalance leads to a functional imbalance in the way that the hemispheres can communicate, share information. And essentially, it's like, having two different computers that are in different processing speeds. You have an older computer with a slow processing speed and another computer with a super fast one, and they both work independently. They're not broken, they're not damaged, but they can't communicate with each other. They can't synchronize because they're processing information at different speeds. And as the brain matures, we basically get an upgrade every year to the speed of our processing until we're adults. And so if anything throws off that developmental growth pattern, it can create this imbalance, which is really, I believe, the basis of almost all learning issues, mental health issues, psychological, psychiatric problems. They all fall under this umbrella of functional disconnection syndromes. And the only difference is really, what side of the brain is really overdeveloped and what side is underdeveloped. Is it the right side or the left side? And what areas? Because we have all these different areas of the brain, and how these imbalances and the nature of it is really individualized. But overall, the underlying problem is the same.
Yeah. So functional disconnectivity, and that can also show up in brain injury. Yeah, many ways. We disconnect those through brain injury. That's exactly what we're seeing.
And brain injury is, something I also deal a lot with, but it's interesting because one of the things that very few people look at with brain injury is when you have a brain injury, it can cause a functional disconnection, right? It can separate the hemispheres from communicating. But what's also important to understand is what was the state of those hemispheres and what was the state of the communication before the brain injury, right? So a lot of people, obviously when they have a brain injury, we just assume they were perfectly fine up to that point. And then, we're going to move forward and we look at that point and we look forward. And, sometimes that works fine, but other times it's very difficult to really get the same results and heal the brain. And it's because you're not realizing that there was already this developmental imbalance before the injury. And the injury might have exacerbated it, or it might have been superimposed on top of it. Or it might have created a different imbalance in the other way. And so these are complex things that we need to look at, and very, very important. And I would say that if not understanding that could be the difference between really healing a brain and not healing a brain.
That's beautiful. Yeah, I had my brain scanned with high definition fiber tracking at the University of Pittsburgh, and me and one of the researchers were talking about it as we were going through some of these scans. It was like, we don't have a starting point scan of my brain. We only have what happened afterward, which is why you're like, yeah, if we just assume it was perfect to begin with, but the development of it may have been different. And I had damage specifically to my corpus callosum, is where my diffuse axonal injury is. And that is the connection between left and right hemispheres. So could you talk about the corpus callosum and how that plays into disconnection and connection?
Right. Yeah. And there's two different types of things we look at. One is called a disconnection syndrome, and the other is a functional disconnection syndrome, right? So disconnection syndrome is where, we actually have physical connections where different areas of the brain are physically connected to one another, with synapses, and a large part of that goes through the corpus callosum. So there are these physical wires essentially that connect the two sides of the brain, and there's a flow of information. But that's only one way that the two hemispheres communicate. And the majority of that is really more inhibitory, meaning that it may actually shut down areas on the opposite side of the brain. So when one side is active, sometimes we need two sides of the brain to cooperate. Sometimes we need one side to be active and it needs to shut down the other side so that it's not interfering in what it's doing, because they often do things maybe even in opposition of one another, or we may need to really focus on one function and not so much the other. And so the majority of connectivity in the brain is through what we call functional connectivity. Functional connectivity means, it's partly physical, but the majority of the connections in the brain and the way they link together is really through timing mechanisms, through synchronizing, so that areas of the brain on the right side will come to threshold and fire at the exact same moment as other areas. And those things are linked together through time. And that is it's a much quicker and more efficient way for the brain to be able to communicate, because we want things in the brain to happen really, really fast. And anytime you have to transfer things through a wire, there's automatically a delay, right? And so we have so many cells in our brain. And one of the things is, how is each cell wired to every other cell in the brain? And the answer is no, right? It can't be. I mean, it's way too many. We'd have way too many connections. And we already have, 100 billion neurons with 100 trillion connections. So, the idea is, well, how do we actually then connect, a certain area of the brain with a certain area of the brain if nothing is all physically connected? And so there are different steps, and we have different distribution in the brain. But again, a lot of it really comes down to timing, and timing is a product of maturation. As our brain grows, it becomes faster. And so if we have this maturational imbalance, it can interfere the ability of areas of the brain to fire at the same time. And even though we may have good transfer across the corpus callosum, we may not be able to really link areas of the brain together. And that's the difference between a functional disconnection and a disconnection syndrome, where there's actual injury or disruption of the physical fibers that connect the brain.
Right. So functional disconnection would be like inefficiencies in that communication between those,
Right.
as a result. So what causes brain imbalances?
Well, more often than not, again, it happens in development. As we said, it could happen with injury, and there's other things that can happen. But, the vast majority is a developmental imbalance. And so this can happen in the womb, or either, during development, and especially through the first 6 years. When the brain is developing, the right side of the brain develops first. It's most active first. So both sides of the brain are developing, both sides of the brain are growing. All of the input that's coming into the brain is impacting both sides. But the right brain is about 20 or 30% more active during the first 3 years. So what happens is anything that's coming in during that time, any experiences in the womb or early on, is going to have more of an impact on the right brain. So it changes the right brain a little bit. The right brain becomes a little bit more sensitized to that type of input. Like, for example, when we're first born, we don't see clear, detailed vision. And we're really only seeing out of the peripheral field of our vision. And there are certain receptors called magnocellular receptors that are more active during that time. And so we see just kind of outlines and shades of gray and movement, but we're very good at looking at movement, quick movement. So the brain is more in tune to that. So babies, when they're born, they're not really seeing clear vision. They're able to see and especially biological movement, physical movement of like the parents' faces, or, part of the reason why we have white eyes and we have eyebrows is so the baby can actually see our facial expression during that time, and they get tuned into that. And so the right brain is always more attuned to more, grainy outlines, shades of gray, the general big picture of an outline, and more movement. Just like in the womb, the baby's not hearing clear, detailed voices and letters and words and syllables, but the baby does recognize the parents' voices, and they can hear tone of voice, and they can connect it to the emotional tone of the voice. So we know that the baby comes out already recognizing their parents' voice and can react to, whether it's happy or sad or angry tone of voice. And so the right brain is always more in tune to tone of voice and nonverbal communication, which is the earliest form of communication. The right brain is more about the big picture and big muscles and big movements, which is really what's happening early on in development. It's also about attachment. It's about forming relationships with another human, maintaining those relationships, and developing nonverbal communication, which is the foundation of developing social skills. So the right brain is more social. It's more emotional. It connects to our own body. It feels our own body early on, so the baby can express when they're in pain or when they're hungry. And the right brain is more cautious. So it's more the emotions, more fear, sadness, disgust, so that we don't eat things that are disgusting or poisoned, and eventually guilt and shame, which is very important to building relationships, knowing when you've made a mistake and being able to, have a sense of conscience. So all of this is developing more in the right brain in the first 3 years. We also don't really form conscious memories during that time, which is why most people don't remember before the age of 3. This is called childhood amnesia. But then around 3 years of age, now the left brain starts to kick in. And the left brain now is more about detail. So we're seeing much more clear vision. We're able to hear much more high frequency sounds and syllables, and we can process much more detailed information, and we have receptors to see the world and hear the world and feel the world in a more detailed way. And the left brain is processing much more information, and it does it more sequentially and linearly, where the right brain sees the whole picture all at once. The left brain now starts to process things one step at a time and try to figure out patterns. The right brain has a past and a future, where the right brain is really only in the present. And the left brain is more about fine motor skills, and it's more about verbal communication, and it's more about learning, consciously learning and setting goals, and being aware if you're achieving those goals, and being more motor driven and more motivated to go after certain goals. And the right brain and the left brain also, generally the right brain is more withdrawal, it's more cautious, it's more sensory. The left brain is more motor and more approach. And that's the way our immune system works too. So the right brain will shut off our immune system or dampen it. The left brain activates the immune system. And so if you have an imbalance where the left brain is high and the right brain is low, underdeveloped, as in ADHD or OCD or tics or Tourette's or autism or schizophrenia, you tend to see those people have overactive immune systems. They're prone to food sensitivities and eczema and autoimmune disorders. Whereas people with a left brain delay, like dyslexia or learning disabilities, it's the opposite, where they have a weak immune system and they have chronic illnesses that they can't overcome. And, we see this just in general. The left brain activates things, and it gets an idea, it gets a thought, it wants to move. And the right brain says, okay, don't do that. It's not appropriate right now. Or the left brain does it, and then the right brain says, okay, let's stop. Let's move on to the next thing, because you've done that. And the left brain wants to keep on doing it over and over and over. So the left brain is naturally impulsive, compulsive, addictive, hyperactive. So again, when we see any of those issues, it's because the left brain is too high and the right brain isn't there to stop it.
Hmm. So I like that that inhibitory aspect of the right brain being, stopping things from going haywire, and also thinking about in my own recovery, it's very much rebuilding connections in the brain are very much like redeveloping, reconnecting. So
Yes.
it's like development all over again. And a lot of my work was in developmental nutrition, because we need the same ingredients to rebuild
Yeah.
the brain as we do to build the brain.
Right.
Um, and I think that's a really important thing to for people to understand, is that the developing brain and the redeveloping brain. You talked about amnesia in before age 3, and we have post-traumatic and amnesia, for example, as well. And I think that's also really strong parallel
It's
in there.
really, really important. And that's another thing that I think is kind of unique in the approach looking at developmental aspect, is because, there are things called primitive reflexes. And these reflexes are reflexes that we're born with that allow us to really engage the world and move and interact with the world, which we need to, because we're born with a basic operating system in our brain. And it can do almost everything that we need to do, but it doesn't mean anything until we actually calibrate it to the real world, right? So we have to be able to move and interact. And we don't really have a motor cortex yet. We don't really have a brain yet when we're first born. So how do we move? How do we interact with the world? How do we feed ourselves? How do we protect ourselves when we're just newborn infants? And so we're born with these things called primitive reflexes. They're actually there even before we're born, because they actually help us birth ourselves to a certain extent. They help us push ourselves out of the canal, and turn and twist through the canal and push out. And then they will help to allow us to root and suck so that we can feed ourselves, grasp onto things, have a startle response, which allows us to react and know when we're in danger, to be able to roll over and get on our belly, and eventually then get up on all fours and crawl, and then eventually stand up and start cruising, and then eventually walk at around 12 months. And those milestones are critically important. And they've been so downplayed of late, because there's so many people that are saying, well, it doesn't matter when we crawl or when we walk. That's completely untrue.
Mm-hmm.
And what we've seen is that we know that things like the Babinski reflex and other reflexes like that, like rooting and sucking reflexes and snout responses, that those are reflexes that are primitive reflexes that we're born with and go away. All of them should go away at about 1 year. They don't go away completely. They become integrated into the nervous system. And so therefore, if the brain is injured, they return.
Mm-hmm.
And so, my approach is that when I'm working with anybody, whether they're a brain injury or not, the first thing I'm looking for is, are there primitive reflexes there? And we have to reintegrate them or integrate them initially. And this is the basis of my PhD right now. I'm doing a PhD in cognitive neuroscience, and I'm working with a team of really great neurologists and around the world, and in Cuba and Israel. And I've trained them on how to look for primitive reflexes, not just in infants, but in everybody of every age. And we're working with autistic individuals now, and they can't believe what they're finding. They're just blown away by this, and they're never taught any of this. Pediatric neurologists look at primitive reflexes routinely in infants, but they never look at them beyond one year of age. But we all know that something like the Babinski sign, which is where you stroke the foot and the toe goes back, everybody's taught that comes about in brain injury. So that's a returned reflex. We also know that many of these reflexes come back later on in life with old age, with neurodegeneration. So with Alzheimer's or dementia, we see that many of these reflexes return. But what most people don't realize is those reflexes actually start out as primitive reflexes in infants. And so they may never go away. And if they don't go away in that first year, they may stay there your whole life. And they actually prevent appropriate development. I believe they're often the foundation of why we develop this imbalance. They hold back the development of the brain, and the other side kicks in too strongly, especially in people that are gifted in that area.
So this is really great, talking about primitive reflexes. That was a big thing that was done in my recovery as well, is figuring out what reflexes are coming back and are not integrated anymore. And I'm curious, what are some of the tools you'll do with say an adult who's presenting with primitive reflexes, or a child that's presenting with unintegrated primitive reflexes at an age where they should be integrated by that time?
Yeah. So, I've really been focused on a lot of nonverbal autistic kids or some genetic or brain or disordered adults. And it's interesting because we see those reflexes there in both populations. And in my PhD, we talk about the difference between retained versus returned reflexes. And so the principle behind it is that we want to try to integrate these reflexes, whether they have never been integrated or whether they were integrated and then they're not integrated. You just said that before beautifully. So what I've found is that, traditionally anybody that does this work, which is not a lot, to be honest, and there has been very little published on this. So we believe that we're going to be starting a whole new area of science that's going to explode over the next few years. You're going to hear a lot about this. And we've done literature search on how many papers have been written in this subject, and it's very, very few. And so when it comes to primitive reflexes, autism, and cognitive function, there's almost none. And so, we believe we're going to start that. And so the idea is, how do we integrate them? And so traditionally it's been by trying to reproduce the movement and do them over and over and over and over and over. And as you do that, eventually they become inhibited or integrated within the nervous system. So there's a series of exercises that have been around for a long time that people talk about, things like the starfish for the Moreau reflex, or the lizard, or the reverse lizard, or, angels in the snow. And so there's basic ones. And, there's a lot of different reflexes. There's 30 or 40, I think, different primitive reflexes. And, there's some people out there that teach all of them. I have used all of them, but my experience says we only need to focus on like 6 to 8 of them. These are the foundational ones. And I believe if you those are the ones that most commonly come back. And those are the ones that if you reintegrate them, I think all the other ones mostly fall into place.
So for the audience, I want to kind of do a quick explanation of what we're talking about. With snow angels, it's laying down and doing snow angels. What else did you talk about? Different, but basically
starfish, which is where you kind of go like this.
Right. And that's for Moreau.
And then the lizard is where you're laying on your stomach. And then there's what's called a cannonball. And there's other exercises you can do for the Palmer and for the Babinski.
So these are basically just movements and motions in a certain sequence in a way to get your brain to integrate that motor function,
right,
rather than reacting from a limbic place.
Yeah, but the thing that I've found really, because what I've been working with are, again, young children or very low functioning autistic individuals or people with brain injury or genetic disorders that can't do exercises. So the question is, now what do you do, right? And this is the thing. Most people think only exercises. And what I've been able to really find over the last few years is that what's most effective is I train the parents or caregivers to stimulate the reflexes the way we examine for them, right? So like, for instance, if I want to look at a rooting reflex, I'll take a brush and I stroke from the cheek to the corner of the mouth and over the lips. And I'm looking for this contraction of the mouth and the lips. And the pressure you put and the location is everything. If I stroke up here, I won't get the reflex. If I stroke down here, I won't get the reflex. If I don't hit the lips with the right pressure, I may not get the reflex. So,
and the reading reflex is a reflex where if you have a brush on the cheek, the baby moves his head towards that brushing
right,
as if it was suckling a nipple.
Right. And so that comes back.
Right.
And or it never goes away. And we see this in full-grown adults. And so the idea is we train them how to do it, like the palmar grasp, you know, is like we do like an X over the hand, and you'll see the hand will contract sometimes. Sometimes it fully contracts. Sometimes it's just one finger moves a little bit like this every time. And so where you do that in the pressure. So this is how I examine for these reflexes. And then I spend a lot of time, you know, training parents how to do it on their own children, and how, or caregivers to do it on a brain injured person. And that is a game changer, because it can be done quickly and easily. Because the two things I found with getting the reflexes, getting rid of them, is you have to do it at a very high repetition. Most people doing the exercises alone, you're not doing enough repetition, because if you're trying to get a kid to do fairly, you know, complex exercises 2 to 3 times a day, they're not doing it. But to stimulate the reflexes can take 5 minutes, and you do it and you don't rely on them. So when you're dealing with a small child or a low functioning individual or a brain injured person, you can't rely on them to do anything right now in the beginning, right? So everything has to be done to them. So you have to use reflexes to be able to do that, like the primitive reflexes, the optokinetic reflex, the vestibular ocular reflex, other postural reflexes that we'll use as well. And then as we start to build plasticity back into the nervous system, or for the first time, then we see that they're able to start engaging. And then down the road, we may get them to do exercises as well, or that may be the primary focus at the end. But the idea of stimulating the reflexes, doing it at a very high frequency, and doing it also with hemispheric balancing at the same time, those are the critical things. And if you don't do all of those together, then I find that you may not get, you know, the same results.
Yeah, so let's talk about what happens when you have a child who comes into the school system, for example, and they have ADD or dyslexia or whatever, these brain imbalances, as we're talking about. What typically is the course of action, and what do you do differently?
Yeah, the course of action, first of all, you know, and I don't mean, I have the utmost respect for educators or any other therapists working. I just had a great conversation with a group of people from school educators and therapists in New Hampshire about a child that we're working with, and they were, you know, really loving it, because they really always looking for something new to do, right? Because a lot of the things they do don't work so great, because they're not really understanding what the actual problem is, right? They don't know what the problem is. And again, every lecture that I've started over the past, you know, 20 years, whatever audience I'm lecturing to, from parents to neurosurgeons or neurologists, I always say, you know, who can tell me what's actually happening in the brain? And, you know, raise your hand if you can do that. And most people, if they're honest, raise their hand, they have no clue. And so, you know, at all levels, I mean, even pediatric neurologists, they don't know neuroscience. The neurologists that I work with tell me all the time, we never knew any of this stuff before we started taking your courses. And so it handicaps them. And so the model in education is typically more of a compensation model. So I have a degree in rehabilitation neuropsychology, and I've worked with a lot of brain injured in some of the top brain injured places. And in that rehabilitation neuropsychology, there's two models. One model is a compensation model that we think, okay, we can't really fix this or heal this. So let's just teach them how to compensate. Let's give them a cane. Let's teach them how to use, memory devices or whatever. And then there's a whole nother school of thought based on neuroplasticity that says, no, we can actually try to heal these things. We can actually try to correct them. And that's in brain injury. And remember that, children that have ADHD or dyslexia, they don't have any injury to their brain. And one of the things really important to understand that other reason why these imbalances develop is because, in fact, almost anybody that has an imbalance that's developmental, even in cases of severe autism, it's because they generally have genius level skills and they have a certain level area on one side of the brain that's too strong. And we know this for a fact. I mean, Simon Baron-Cohen out of Cambridge has done studies showing that, that there's a trait called an autism trait. And it runs in families where we have highly intelligent people. It's also known as an intellect trait. And you have, people that have families where they have, physics professors or math professors or anywhere in the IT world, like Silicon Valley or other places in the world where there's these people in the IT, engineers, computer technology. There's an explosion of autism, and especially high functioning autism in those areas. Like it's 1 in 10 in Silicon Valley. 1 in 10 kids have Asperger's, basically. And it's not because there's anything wrong. It's because there's a trait. And actually, as you go up the socioeconomic scale, as you go up in IQ level and income level, you actually have more kids with autism. And so it's not a disorder of neglect or something wrong. It's actually, they get too strong of a trait. And that trait for me is a left brain dominant trait. So their left brain is unbelievably strong. And if their right brain doesn't match, then they can develop this imbalance. And then if they have retained reflexes, it kicks it into high gear. And this is what I believe is actually the source of the problem. It's a combination of a normal trait. On the other side, it's what we call a creativity trait, where we see bipolar disorder and dyslexia. We see people in those families are very in the creative world, even though both sides of the brain are creative. But, people like Hemingway and writers and famous artists, all had bipolar, and it tends to run in those families, but they're incredibly gifted, right? Like dyslexia runs in families of people where they're great athletes. So, there's these traits that set it up, but then there's these imbalances and then the primitive reflexes and then other things that may delay the development. And this is where these imbalances come from.
Beautiful. And I'm looking at your background. You have the Melilla Method right there. And I wanted to ask you about that.
Yeah, well, I created something called Brain Balance Achievement Centers. There's over 100 centers, and I created, it was an academic education-based program for children. And again, it was, something that I started working on, over 25 years ago. And we created these centers and this program to be able to help those kids. But I didn't design it at the time really for severe nonverbal autism, for brain injury, for genetic disorders. And it's really a non-medical, non-healthcare model. It's an education-based model. And for, the average kid, high functioning kid with ADHD or a learning disability, and it works great. It's still the best model out there. But, I wanted to create something that was for the most severe issues. So what I did, once that was up and running and, I didn't really need to do a lot with it anymore, I turned my focus on, okay, I really want to perfect and really develop a new model, a completely different model that is more healthcare based, that uses cutting edge science, medical, therapeutic tools that is really geared towards all of those other issues, like nonverbal autism, and brain injury, genetic disorders, and even, things like schizophrenia and bipolar in adults. And so, over the past 5 years or so, I've been traveling the world, really working with the most difficult cases I can get my hands on. And also part of my PhD process has been looking at this as well and doing the research on it. And I've been working and perfecting, clinically. And the good thing about COVID is basically, it stopped me from traveling and and so it allowed me to really focus on my practice in New York and really focus on people that I would see on a regular basis. And so with that is really what we call the Melilla Method. It's basically a different level. It's another model that is really very different from any model that I created for, but I believe it's the ultimate evolution of what I've done and what I've created. And, it's something that is, again, directed towards, in general, a more severe population. It still works also with high functioning people and kids and everything. We work with a variety of different issues, but really we can work with anybody from any age. In my center, we have an adult section, we have a kids section, and we can work with them. Quite often, one of the things that frustrated me also was we'd be working with a child and they may have an issue, and then we realize that their parent had the same issue growing up and it was never dealt with. And there's an interaction there, meaning that the adult brain affects the child brain. So if the parent has a significant brain imbalance that they're living with, and their child, we're trying to correct this in their child, but that parent inadvertently will literally bring that brain back down, right? Because their brain is the biggest influence on their child's brain. Lou Cozolino, a really famous psychologist that I read a lot of his stuff and also I've become friends with, he talks about this, how in psychology, like the right brain speaks to the right brain and the left brain speaks to the left, and it can drag these things down. So we're able to now work on the parent at the same time that we work on the child. And sometimes, unless we correct these issues in the parent, we won't fully correct them in the child. It's a pretty fascinating area. So now, we have no limitations, and I've created a whole new center around that here in New York called the Melillo Center for Developing Minds. And it utilizes the Melilla Method. And we have people now trained all over the world. There's a certification and a fellowship in this method that I teach. And, so this is what I believe is where the future is going. And we just want to spread that around the world and give people access to it.
I love that awareness of kind of entrainment back to what your sensory diet is mostly consists of. So if it's a child and their mother's brain is a certain way, and they can do all the therapy and things with you or one of the practitioners, and then going back and you're still in the way of things that entrains it in the way it entrains it. We have a good amount of practitioners that also listen to this podcast, and I went to your website, drrobbermelillo.com. Is that right?
.com, yep.
Yep. And you have resources, courses as well for practitioners.
Yes, I have my course that I've been teaching, for over 25 years, almost 30 years. That is a fellowship certification course for health professionals. It's also a certification course for non-health professionals, because I have parents that actually go through the course because they're desperate to learn this. And it really is, I think, the most cutting edge course that's available. And it discusses, what's actually happening in the brain in things like ADHD and autism and dyslexia and learning disabilities and OCD and Tourette's and tic disorders and eating disorders and all of the things. And it's online, And so people can access it from anywhere, and it's updated. We are going to be teaching it live in Dallas in starting in February. I have three doctors that also, co-teach it with me. And, it is important because a lot of this is also hands-on, learning the right techniques. And then I've also just created really what for me, which is I think my ultimate course, which is this advanced functional neuro and clinical neuroanatomy course. Because, when I'm training doctors and therapists, the thing that really holds them up or may challenge them is if they don't really understand the neuroanatomy and the functional neuroanatomy, meaning, what areas of the brain, how they connect, how they communicate, how the brain develops, how the brain actually works. And so I created this 4 modules that, is really probably the most advanced neuroscience course that almost anybody will take. It's like a PhD level course in 4 modules, but it's all clinically and functionally directed. And it's really fun to put together, fun to teach. And that is also a really neat course that's available online as well.
Beautiful, beautiful. Any other place where people can learn more about you?
Well, I'm very active on social media. I'm on Instagram, and I put a lot of videos up and a lot of educational things on that, and Facebook. So Dr. Robert Melillo is at my Instagram and my Facebook page. And I also have a personal development kind of / inspirational page called Better Than Good, the Science of Success and Happiness. And, we put videos up there as well, give people tools, because bottom line is even, achieving goals and being motivated and forming habits, it's all neurological. It all comes down to the brain. It all comes down to different areas of the brain. And many people have trouble setting goals and forming habits or breaking bad habits because they have imbalances in their brain that they don't know. And what I'm excited is in the upcoming year, I think I'm scheduled to do two different TEDx talks. So I hope who's ever out there will, look for that when it comes out and share it, because I'll be doing one particularly on, what is a brain imbalance and what do you do about it, and how does it influence us?
Beautiful. All right. Well, so looking forward to it, and thank you so much for being here for this for this podcast. I appreciate you so much, Dr. Melillo, and I might just see you in February. We'll see what happens.
Okay, I hope so. Come up to to Dallas.
Not too far.
Yeah, and we have you can come up with Dr. Crawford, Dr. Brandon Crawford.
Yes, exactly.
He'll be teaching with me along with Dr. Kyle Daigle and Dr. Peter Schreier.
I figured as much. We've had Dr. Daigle on the podcast. I've not had Dr. Crawford yet.
Yeah,
we'll change that. We'll change that very soon.
Yeah, because he's doing some really cutting edge stuff with children with anoxic brain injury. Kids that have like drowned and died and were brought back. I work with some of that as well, but he's really that's a lot of what he does. So fascinating stuff.
Yeah. Well, thank you so much, Dr. Melillo.
Well, it's my pleasure. Thank you. Thank you for what you're doing. Thank you for being you.
I wouldn't do it any other way. Thanks, brother. All right, so now you know of Robert Melillo, the Melilla Method, practitioner training in the hemisphericity model of the brain. I'm really looking forward to diving more into it. And thank you guys for listening to the end. As you may know, my podcast had some troubles with iTunes, and I had to reset it, basically take it off of iTunes and put it back on. So I lost all of my reviews. And so it would be super appreciative if you go to feedabrain.com/iTunes. I made it easy. That'll take you right to where you leave a review on iTunes. So go over there and leave me a review. It would be so appreciated. Thank you guys so much for being here, and I'll catch you on the next one.
Someone take me to a doctor.